Hey guys, good morning. I've got your homework from section 3.3. We're on page 207 and we are looking at, in number 11, changing the base. So if we have a log base 2.6 of x, we would write that as log of x divided by log of 2.6. Let's see, it says change it as a ratio of natural logarithms. Hold on just a second. Okay, so that's just, so this is part A, and then natural logarithms would be the natural log of x over the natural log of 2.6. And natural log just has an understood base of e, but we don't have to worry about that. Number 14. We need to actually evaluate it. So if we have a log base 7 of 4, in our calculator we would type in log of 4 divide by log of 7, and 4 log divided by 7 log, that's 0.7124. And it says 3 decimal places, so 712. Number 17, same thing, we have a log 6 of 0.9, and so I would do 0.9 log divided by 0.9 log divided by 6 log equals negative 0.059. And number 20, log base 20 of 175. .7. 21. Alright, the natural log of 20, well, so we're rewriting this in terms of natural log of 4 and natural log of 5. So let's first of all think of 20 as 4 times 5, not 4.5, 4 times 5. And then we would use our product property to split that apart, so the natural log of 4 plus the natural log of 5. In number 22, we've got the natural log of 500. So how could we rewrite that using 4s and 5s? So let me think about that for a minute. 500 is 4 times 125, right? Yes, and 125 is 5 to the 3rd power. So I'm thinking if I start off by writing it like this, and then I want to split that apart, natural log of 4 plus natural log of 5 to the 3rd, and then I would use my power property and bring that power out in front. So this is a skill that you just need to practice, visualizing how these numbers break down, and it'll actually be easier once there's a bunch of variables involved. Okay, so in number 25, the problem says log base b of 25. So let's get some directions. Approximate the logarithm using the properties of logs given log base b of 2, log base b of 3, and log base b of 5. So we know a number value for log base b of 5, so I want to rewrite this 25 in terms of log base b of 5 squared. So that would be 2 times log base b of 5, and then they told us log base b of 5 is 0.8271. So I just need to multiply 2 times 0.8271 and get 1.6542. In number 29, let's see, we want to graph the logarithm. So log base 3 of x plus 2 use the change of base formula. So natural log of x plus 2 over natural log of 3. And so I'm going to start up my Desmos utility and see if I can figure out how to graph a natural log. You guys, it'll be much easier with your TI calculators. Okay, so this is my Desmos app. I went into functions and the natural log is over in the miscellaneous. So I've got natural log of x plus 2 close parentheses divided by, and then I need to do the natural log of 3. So I'm going to go back into my functions and do natural log of 3. And that's showing me that it's in the denominator. So there we go. It looks like a standard log. Let me zoom in. So that is between 1 and 2, but much closer to the 1. And then well, look at that, my x-intercept is 2 to the left. And what do you know? There was an h value telling me to move this thing 2 to the left. And my asymptote, does it cross over that line? Looks like it never does. So my asymptote is just asymptote is 2 to the left, sorry. And then my intercept is at 1. So here's the graph. We're getting closer and closer to -2. Okay, so that makes sense. Alright, number 31. F of x equals log base 1/2 of x minus 2. So again, to graph this, we would want to go log of x minus 2 over log of 1/2. And apparently in this section, we want to use natural log. So let me correct that. Okay, so now let me put that in, and I'm going to use this same, okay, there's x minus 2, and there is 0.5. So, what happened to my graph? So we know with exponents, weird things happen when we have fractions. They can change things from growth into decay. I'm trying to figure out a good place to put all this. I think I just need to move my camera. Okay, so first of all, I don't know if you can see this very well, but my asymptote has moved over 2 to the right, which makes sense because I have this minus 2 here. So I'm going to sketch that in first thing, and then my intercept is here at 3, and my graph is, I don't need to make that a dashed line, my graph is inverted, so looks something like this. Alright, in number 33, f of x equals log base 1/4 of x squared. So we'll go natural log of x squared over natural log of 1/4. So I'm here's what I'm expecting. This would come out here where an A would be, or a vertical stretch. This is going to probably invert things and make it look more like a decay. So let's try it. So let me go back in here and just replace my other function with x squared over 0.25. And I've got some kind of a caution here. Sorry, I don't understand this. So see, having the x squared in there is probably too confusing. So let me bring it out to the front using my power property. Oh, no, the confusing thing was the 2 decimal points that I had. Okay, so either way, this is an equivalent expression. We've got an asymptote at 0, which we didn't have any h's or k's, so that makes sense. So let me sketch that in a different color. And my intercept is at 1. So, and I've got a decay shape. Okay, let me go to a new sheet of paper and adjust my camera. So now I'm on number 35. And that'll be the last one of these, which you'll probably be glad about that. Here's x over 2. So let me simplify this a little bit. First of all, I'll do natural log of x over 2, and then natural log of a half. And let's see if our calculator understands that. X over 2. Let me get rid of this 2 out here, and then this is back to being a half down here. Okay. So let's see. It is the exact same. No, it's not the exact same. Okay, so here I've got 2 as my crossing point. My asymptote is still at 0 because I don't have any h's or k's. I'm still following this decay shape. Alright, number 37. We're going to simplify the logarithm using the properties. So log base 4 of 8 is log of 8 over log of 4. And 39, log base 2 of 4 squared times 3 to the 4th. I can't 100% tell. I feel like this 3 to the 4th is separate, so let me go ahead and do a few things. I'm going to change this to an 81. I'm going to take this and put it in the front. 2 times the log base 2 of 4 times 81. And then from our game and from the things we were doing in our head on Monday, I know that the log base 2 of 4, if I just break it out separately, 2 to the what equals 4? Well, that's 2 to the 2. So I can replace this whole thing with a 2. So now I've got 2 times 2 times 81, which 4 times 81 is what? 324. In number 41, the natural log of 5e to the 6th. So we're going to use, it looks like we've got a product and a power, so we're going to use both. We're going to go natural log of 5 plus natural log 6 times the natural log of e. And the natural log of e is just 1, because they're inverses of each other. So I'm going to say natural log of 5 plus 1. Oh, 1 times 6, which is 6. And I have no idea if that's right. I'm going to check my answer in the back to that one. It feels right, but I better make sure. Okay, that was right. So now number 43 is our last one from this group, and we've got natural log of 6 over e squared. And so that's a division, so I'm going to use my quotient property to do natural log of 6 minus natural log of e squared. Natural log of 6 minus 2 times natural log of e, that's 1. So natural log of 6 minus 2 will be my final answer. And you could go further if you had a calculator and you were just plugging these in. But the answer in the back should match that. Alright, and now we're going to go to number 47. We're going to do 47 through 59 odd. So we're going to expand. And 47, we have the log base 10 of 5x. So that's a product. So log base 10 of 5 plus log base 10 of x. And that's really as far as we can go, because 10, there's no easy 10 to the what equals 5. Number 49, log base 10 of t over 8 equals log base 10 of t minus log base 10 of 8. So I'm just breaking these apart using the quotient property. In number 51, we've got log base 8 of x to the 4th. And so that's a power, so I'm going to take that out front. 10 times the log base 8 of x. Sorry, 4 times log base 8 of x. In number 53, we've got natural log of the square root of z. And I'm just going to rewrite that using a power. And that way I have a number to bring out in front. And 55, just don't want to go off the edge of the camera here. Natural log of xyz is the same as natural log of x plus natural log of y plus natural log of z. 57 is log base 6. Ooh, this one's got a lot of stuff in it. Log base 6 of ab cubed c squared. So I'm going to break this into, it's a product of 3 things. 2 of them have exponents, so I'll use the power property, and then the whole thing at the end I will just divide by the log of 6. So we'll have log of a plus 3 log b plus 2 log c, all divided by log of 6. And then my last problem, I don't want to start a new sheet, so I'm going to squeeze that over here on the side. Number 59 is the natural log of the cube root of x over y. So I'm going to rewrite that as x over y to the 1/3. And then I'm going to use the power property and the quotient property. And I have to be careful. This 1/3 is of both. So I have to have a third of both. So I put those in parentheses. And that's my final answer. And that's it for 3-3. Thanks for watching.